Happy Friday. Okay. Okay. Yeah, yeah. All right. So we get to now we get to move these hyperbolas and ellipses off of the origin and somewhere around on the XY plane. We'll keep their orientations essentially the same, but we will move them. I will review for you how we move the parabolas and circles so you kind of get a little feel for this. So I don't want a red pen. Scared them off? That's it. It is kind of scary. So for parabolas, my basic forms of parabolas are y equals ax squared and x equals ay squared. The y equals are the vertically oriented, the x equals are the horizontally oriented. And we have known how to move those off the xy plane, around the xy plane, by moving the vertex around. So on these, the vertex is at the origin, 0, 0. And if I rewrite my equation as y equals a times x minus h squared plus k, the vertex moves to h comma k. And we learned the same thing with the ones that are horizontally oriented. We have x equals a times y minus k, that's a minus sign there, squared, plus h also puts the vertex at h comma k. Circles. Yes. Sure. So circles, if we have x squared plus y squared equals r squared, then the center of my circle is at 0, 0. But we found if we have x minus h squared plus y minus k squared equals r squared, the center moves to h comma k. Now you need to notice a couple of patterns here. If it's inside the parentheses, it's always a minus sign. The k and the h on the parabolas weren't inside the parentheses, so they end up being a plus. We end up not changing the sign on those. The h's always stay next to the x's. They're paired with the x's. The k's get paired with the y's. That's going to happen also for ellipses and hyperbolas. So let's look at the ellipse. So we have x squared over a squared plus y squared over b squared equals 1. Gives us the center at the origin. And if we want to move the center somewhere in the xy plane, we're going to go x minus h squared over a squared plus y minus k squared over b squared equals 1, gives us the center at hk. Yes, ma'am. Yeah, they're both going to change the sign. The h and the k end up changing their sign, you know, if you have, because it's a subtraction going on there inside the parentheses. Okay, so we'll try one of these in just a minute. That's fine. Oh, sorry. I'll give you the formula for the hyperbola first, and then we'll try applying them. So the hyperbola we had kind of different equations for the different orientations. We have x squared over a squared minus y squared over b squared equals 1 for the ones that are oriented horizontally. Or we have y squared over b squared minus x squared over a squared equals 1. Those have center at 0, 0. And we're going to do the same thing. X minus h squared over a squared minus y minus k squared over b squared equals 1. Moves the center of the hyperbola to hk. Or for the vertically oriented, y minus k squared over b squared minus x minus h squared over a squared equals 1. Remember, the k stays with the y, the h stays with the x. So this too has the center at hk. And remember, we do it so that the a's follow the x around and the b's follow the y around. Okay. We ready? You don't look particularly ready, nor excited. Let's translate an ellipse. Okay. I'm going to give you the center. It's going to be at -2, 4. I'm going to give you the major axis. That means the long one is going to be horizontal with a length of 10. And the minor axis, the short one, yes? Major means the longer axis, minor means the shorter axis. I have to tell you whether it's on the horizontal or the vertical if that's all the information I'm giving you. Yeah. Otherwise, I'm giving you A's and B's and stuff like that. But if I'm just describing it this way, I better tell you if it's horizontal or vertical, because that's the only thing you get. So that means the minor axis must be on the vertical. And I'm going to give that one a length of 8. Let me make a little sketch of this. My center is at -2, 1, 2, 3, 4. That didn't work out very well, did it? All right. I need a bigger graph. Okay. -2, 1, 2, 3, 4 is my center. My major axis is going to be horizontal and going to have a total length of 10, which means I go 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 to give me a total length of 10. My minor axis is going to be on the vertical. It's got a total length of 8. Divide that by 2 and go 1, 2, 3, 4. And 1, 2, 3, 4. And my ellipse going out here somewhere. Okay. So I